Very good. So we are recording. Excellent. Thank you so much for attending this technical overview of SUSE Rancher. We're very glad that you are here. My name is Adrian Kosmaczewski. I'm developer relations at VSHN, the DevOps company, and I'm speaking to you from the beautiful city of Zurich in Switzerland. VSHN is a SUSE Rancher partner. We have worked with Rancher for a long time, and we're very happy to run this webinar with them. There's a Q&A box at the bottom of your Zoom client, so please feel free to post questions there. Anything that pops up during the webinar on your mind, I will be very glad to answer the questions to you. And of course, we are going to answer all of the questions at the end, but please don't forget to fill out the question and answer box with whatever doubts you may have. Very good. So let's get started. And here we are. So a little bit about VSHN, because we are running this webinar together with SUSE, but VSHN, maybe you haven't heard about us. First of all, how do you pronounce the name? VSHN, like the I, hence the I in the logo. We are located in Zurich. We are the DevOps company. And since 2014, we help companies adopt the best DevOps practices. And we monitor 24/7. Right now, we're monitoring up to 100,000 different services, from GitLab instances to Jira instances to OpenShift, Rancher, and so many things. So we are your partner for 24/7 IT operation. We have our own products. We run Apuyo, which is a platform as a service provided as well for our customers, based on Rancher, by the way. And we also offer two open source projects, Project Sin, which is used to manage lots of Kubernetes clusters on the cloud, and KTOP, which has recently been adopted by the CNCF. It's right now on the sandbox phase. So we are very, very, very proud to see our Kubernetes backup operator to be accepted by the CNCF and to be in the CNCF family of products. It's a very proud thing for us. So check it out as well, ktop.io. And of course, we do this webinar because we love SUSE and Rancher. We've been using SUSE products and Rancher for a very long time, and we're very, very happy to have you here. But enough about us, of course. What is that we are going to talk about? First of all, we're going to see a brief refresher of Kubernetes, why it is different and what it allows you to do. We'll cover how enterprise Kubernetes has evolved lately and the trends that we are currently seeing on the field, and why do we need enterprise-grade Kubernetes multi-cluster management. Next, we are going to dive into SUSE Rancher. We'll see what it is and how it can help you in your journey with Kubernetes. And you're going to see it's a fantastic product. And for you to get a better understanding of what SUSE Rancher is capable of, we're going to explain you the SUSE Rancher architecture. And finally, we're going to show a little demo to basically give you a taste of what Rancher is capable of, how it does things, and how it can help you. Very good. So before we dive in, let's level the playing field. So a little bit slightly. So the whole reason we're here is because we're embarking on a journey into using containers for your applications or workloads. So let's start with why containers are important. In most cases, organizations like you are coming from a virtualized world. These virtual machines tend to have a larger footprint, require an operating system, they need a specific host or hypervisor, and this is why containers have taken the application development world by storm. Containers are small and lightweight, very simple to build. They only contain the binaries and the required libraries you need to run your application. The container runtime manages the rest. Developers only need to worry about their application as part of the workload. Containers will run almost anywhere, and you can run large numbers of containers on a given host, a much larger scale compared to virtual machines. The benefits are massive, but containers are just almost too easy to spin up. Containers come with their own baggage, of course, because there's no free lunch. You need to manage the container images, you need a way to start them, redeploy them, integrate them together from a complete workload or application. In a lot of cases, your success using containers means you need to manage scaling them up or down as demand changes, which would require balancing running containers across multiple nodes in the cluster to balance resources or workloads. And you still need to manage network communications. As your environment grows, so do the challenges in managing the complex interworkings of containerized workloads. And this is why Kubernetes was built. Google had thousands of containers they needed to manage and orchestrate, and Kubernetes was their answer. Kubernetes is an open source container management and orchestration platform designed to manage thousands of containers. It groups containers that make up an application into logical units for easy management and discovery. Kubernetes, when installed, becomes a cluster. A cluster is comprised of nodes, and each node has certain roles or a combination of roles. There are 3 roles required to create a cluster. You have the control plane, etcd, and the worker node. The control plane manages everything about the cluster. It's like the director of the orchestra. etcd is simply a key value database that stores all of the cluster information, everything, the node names, the pods, everything that runs in them, everything. And the worker node is the one doing the job, doing the work. They are running the containers, making the application your workload. As you can see in this very oversimplified diagram, the Kubernetes master on the left is the control plane which runs the Kube API server, etcd, and other components to manage the cluster. On the right, the Kubernetes node is doing the actual work for the application. It is running those containers. Kubernetes adoption has seen so much success that quickly some higher level requirements have emerged, especially when aiming to successfully adopt it across the enterprise for real life production workloads. And this is where the need for multi-cluster and multi-cloud management comes to the fore. Let's look into it. This is all related with how the adoption of Kubernetes has evolved. At the beginning, early adopters of Kubernetes began building infrastructure in the same way they had done previously, building large homogeneous clusters. Learning from those experiences, they quickly realized and understood that this was very hard to scale and evolve to their needs. Different workloads have different needs. Example, an AI or machine learning application has completely different requirements to a business process management app. Cloud infrastructure also came into account, and some workloads were to be migrated there or specifically created to take advantage of the new capabilities and flexibility provided by those environments. Large clusters simply could not adapt fast enough. Today, companies are using multiple clusters and different Kubernetes distributions. They have multi-cloud strategies, and each cloud has their own hosted Kubernetes service, like Elastic Kubernetes service on Azure, on Amazon, or the Azure Kubernetes service on Azure. When we talk about enterprise-wide adoption, it can be difficult to handle the overhead and risk introduced by not deploying, managing, and securing all of those different pieces in the right moment, in the right way. The reality is that there is a significant need for being able to manage all of these clusters in a consistent way through a consistent interface and through similar mechanisms. And this is where a Kubernetes management platform like Rancher brings a lot of value. The workload requirements will vary. Where you run your clusters will vary. Some workloads may require GPU, or branch location may have specific requirements for a certain workload, but the whole point is that it doesn't matter. You can set up the most appropriate Kubernetes cluster for each of them. And with Rancher, you have a consistent interface that will enable anyone who needs to interact with any combination of clusters to do so securely, and within the parameters set by the governance dictated by the business, no matter where that cluster resides or what Kubernetes distribution is being used. That gives you an idea of where SUSE Rancher fits and the huge problems that it solves. Let's properly look at SUSE Rancher, how it works, and how this multi-cluster management solution for Kubernetes can help you in the adoption of Kubernetes in your own company. So, as we said previously, Kubernetes environments can grow quite quickly in size, numbers, lots of clusters. Then you have multi-cluster environments. Your users need the right tools to manage their environment. SUSE Rancher is a complete solution for solving the operational challenges that are involved in providing container platforms in an enterprise setting. It provides a common management umbrella that can be laid on top of your Kubernetes ecosystem. Let's look at the Kubernetes layer. Here, you can use a varied mix of Kubernetes environments. SUSE Rancher is able to manage any Kubernetes distribution certified by the CNCF, the Cloud Native Computing Foundation, including SUSE's own Kubernetes distributions, because SUSE provides several Kubernetes distributions, by the way. Some of them are specially built for IoT, like K3S, and other ones are built for enterprise workloads, like RKE, and so on and so forth. SUSE Rancher can also manage the full life cycle of Kubernetes environments provided by the cloud hyperscalers. And this is very important because it doesn't matter whether you're using Amazon EKS, Microsoft Azure AKS, or Google GKE. SUSE Rancher does not limit organizations to the type of providers for the clusters, whether that is in the data center, in the cloud, or on the edge. As long as you build your clusters within a certified distribution, SUSE Rancher can run it. On the two layers above this cake, you can see how SUSE Rancher takes care of the centralized management of Kubernetes ecosystem, addressing key requirements. First, it provides full lifecycle management capabilities for the different clusters, enabling simplified and consistent operations with capabilities such as cluster provisioning, version management, visibility and diagnostics, monitoring and alerting, and centralized audit. Second, it also provides a consistent set of user access and security policies for multiple clusters, no matter where those clusters are running or the identity access technologies that you already use. Because remember that plain Kubernetes does not have user management. So you need a solution that provides a layer of security on top of your cluster. So even if you're running your clusters yourself with vanilla Kubernetes, you still have to think about user management. Rancher provides a rich ecosystem catalog of value-added services. So with one click, you can install lots of cloud-native applications available on the landscape for building, deploying, and scaling containerized applications, including distributed persistent containerized storage, monitoring, packaging, connectivity, logging, among others. SUSE Rancher really allows users to unlock the full potential of Kubernetes across their business. So let's get a better idea of how SUSE Rancher works and its place, role, and interactions in the overall architecture. SUSE Rancher can be deployed on a Kubernetes cluster of your choice. It is supported on SUSE Rancher's own distributions, RKE and K3S, whether on-premise or on the cloud. And it can also be deployed on EKS, AKS, and GKE, the three main public cloud Kubernetes services. It is easy to deploy with these distributions, but nobody needs to get logged in. SUSE Rancher will work with any CNCF certified Kubernetes distribution. And we at Vision, we have run it with as many distributions you can think of. Even Minikube works very well with Rancher because simply it is a CNCF certified distribution. Once it is deployed, SUSE Rancher is going to look or wait for you to specify the Kubernetes that you want to manage. So of course it stays waiting, it asks you to provide that configuration. And SUSE Rancher can then deploy clusters on-prem using existing infrastructure or using vSphere to provision new virtual machines. And it can also deploy in an infrastructure or hosted provider to leverage cloud resources or even a hosted Kubernetes distribution. SUSE Rancher can also import any existing clusters that run on a CNCF certified distribution, including those at the edge with K3S. So there we go. Once those clusters are provisioned, SUSE Rancher brings capabilities that allow to centrally manage many important management tasks for all of those clusters. And for each individual cluster, SUSE Rancher has out-of-the-box tooling and integrations with solutions that everyone needs for a true production-grade Kubernetes cluster. In addition, SUSE Rancher is not typically deployed into a completely greenfield environment. It can leverage existing systems that you already have without locking to a particular technology stack. So let's look a little bit more in detail to those capabilities. And there we go. This is the complete picture. So let's start with operations and management. SUSE Rancher provides a consistent UI to provision Kubernetes across any infrastructure provider. You can trust SUSE Rancher as the single point of provisioning, but you can also use your existing provisioning mechanisms if you choose to do so. SUSE Rancher also serves as a single pane of glass for you to modify, upgrade, and backup clusters wherever they are. So you can manage the complete life cycle of your clusters in a consistent way, because SUSE Rancher can abstract the differences between different infrastructure or Kubernetes providers. Via the SUSE Rancher UI, everything is the same, everything is managed in the same way, upgrades are managed in the same way, applications are rolled out in the same way, and security policies are set in the same way. This capability is very powerful for organizations with a hybrid IT or multi-cloud provider strategy, because you don't have to integrate with every provider. Instead, you just use one tool that fits them all, which is SUSE Rancher. It also has first-class support of cloud-hosted Kubernetes on all of the three main cloud providers, AWS, Azure, and Google. And you can get operators for other clouds that allow you to manage those as well. This allows you to apply consistent processes and consistent interfaces, even if the Kubernetes cluster has not been installed by SUSE Rancher. I'll talk more about this in a moment. Finally, SUSE Rancher has a powerful web UI and even more powerful API in the back driving it. You can leverage this API directly with automation and integration with third-party services, tools, and frameworks to provision and onboard users to Kubernetes service in an enterprise setting. We briefly touched before on the cloud support. Now let's look a little bit more into it. SUSE Rancher has full cluster lifecycle management capabilities in all three cloud-hosted Kubernetes services. It started with Amazon AWS EKS in version 2.5, and in the latest version 2.6. It has been expanded to Azure AKS and Google JKA. This is something you will only find in SUSE Rancher. It expands Rancher ability to manage multi-cloud environments using multiple providers from a single central point, all via Rancher, which can take over the management and upgrades of the Kubernetes layer. There are now more configuration options available, whether the cluster is being created from scratch, or it is an existing cluster in these hosted environments that is being imported. The existing hosted clusters with these cloud providers are treated as first-class citizens, regardless if they were deployed by some other mechanisms. These can be integrated into a Rancher platform and managed in the same way as if they had been provisioned using Rancher itself. The full lifecycle management capabilities are performed in the same way, and users can leverage the same CNCF tooling for all of them. Why is this important? Well, because it gives you a way to normalize your tooling to the CNCF functions without having to go deep and learn each cloud provider's proprietary built-in and logged-in solutions. Instead, there is a common baseline of configuration for Kubernetes that is portable across all of the cloud providers. And this is especially important for you, as you must maintain containerized workloads on-premise and in the cloud, and even more if you are working with different cloud providers in your infrastructure. Security is another focus area that is becoming more and more important as we see organizations migrating and deploying more critical applications and containers and clusters in production environments. SUSE Rancher provides the authentication for all the clusters that it manages. It uses an authentication proxy that it integrates with the enterprise's main authentication providers, like Active Directory, Okta, any LDAP provider, you name it, OpenID, you name it. You most likely don't want to manage different authentication systems for on-premise and on-cloud clusters. So SUSE Rancher reduces this complexity by integrating all of the clusters under the same authentication provider of your choice. And as additional clusters get provisioned, those clusters automatically inherit and benefit from this central authentication. Remember what I told you, that plain Kubernetes does not have user management, so you really need something like this. In addition, SUSE Rancher built on top of the Kubernetes role-based authentication model to provide role-based access to users and groups at every level within the architecture. What users and groups can do at the Rancher level with the central management task? What can they do in each individual cluster? What can they do with every namespace? What can they do at every application? SUSE Rancher makes it very easy to manage multi-tenant clusters using constructs such as projects that allow a group of users to share the same underlying resources without interacting with each other's application. It even manages making it possible to have project-level network isolation. A very important capability in SUSE Rancher is the central management of security and network policies. Managing these policies manually is not feasible in large settings. IT Ops applies the policies to SUSE Rancher, and SUSE Rancher applies those policies at the cluster level, doing it in a continuous fashion, so that if there is some configuration mismatch, SUSE Rancher automatically repairs the situation. This is an advantage both from the operations point of view and from the security point of view. SUSE Rancher has different features for hardening the clusters. It can use cluster templates to standardize cluster configuration and ensure that Rancher provisioned clusters are created following best practices, or whatever it is that you follow in your company. For RKE clusters, this is the RKE is the engine provided by Rancher itself, the Kubernetes engine provided by Rancher. It can scan for conformity with the benchmarks of the Center for Internet Security. And this is provided off the box, which provides prescriptive guidance for secure configurations of IT infrastructure. They provide best practice guides for both Linux and Kubernetes, among other technologies. And SUSE Rancher also integrates with the Open Policy Agent, which is a very flexible framework for implementing on any kind of organization-specific policies. Talking about hardening, a lot of attention is placed on having secured images for SUSE Rancher. Security all the way from the infrastructure layers. First, common vulnerability scanning is part of Rancher's supply chain. All SUSE Rancher images that are being deployed go through an internal common vulnerability scanning process to ensure that you have the most up-to-date and patched environments. In addition, taking advantage that SUSE and Rancher have come together, they have taken advantage of the opportunity to combine their technologies. This is for all the Rancher components, including the Rancher server. SUSE Rancher is adopting the SUSE Linux Enterprise Base Container Image, BCI. This provides a hardened, company-based operating system that has a secure chain and that leverages the power of SUSE Linux. Also, if you are looking for a base container image for your own projects, this option exists for you as well off the box. SUSE Rancher also provides value to your DevOps teams. It provides you with a very powerful UI for workload management and self-service, giving you an alternative to managing Kubernetes with YAML files in the console, which is the official way most of us use Kubernetes, right? Users can manage the lifecycle of whatever they put inside of their Kubernetes via the browser. Point and click, very simple, very visual. This not only helps with Kubernetes adoption, but it also provides the DevOps users that you choose for with troubleshooting and monitoring capabilities for your respective clusters. This opens up to more clients than just the usual Linux geek. SUSE Rancher also provides an integrated application catalog based on Helm. Helm is the standard application installation mechanism for Kubernetes, and it makes it very easy to deploy and manage lifecycle of standard apps and third-party software. A lot of apps are available through Helm, an incredible amount. Different permissions can be granted to different teams to control who can deploy which Helm charts, where and how and when. And you can also use your own catalogs if you have some, and I recommend that you do have. And SUSE Rancher also provides the option of users doing self-service, turnkey configuration of additional services like logging, monitoring, storage, and additional tools like Service Mesh or continuous delivery. If you are using microservices, you're going to like this. And of course, you can use a GitOps approach on top of all of this. So as you can see, SUSE Rancher can provide value to Kubernetes anywhere, and we will see some of these capabilities in action in the SUSE Rancher demo. At SUSE, we are very pragmatic on providing choice to organizations when it comes to what technologies they want to use. In addition to not being married to any single Kubernetes distribution, SUSE Rancher is not restricted to any specific operating system, infrastructure provider, or even in terms of the toolset that it allows organizations to use. It is designed to be open and to manage mixed environments with open and proprietary technologies alike. This open and flexible approach lets you choose what is best for you. They provide support for SUSE Rancher and other critical components within the SUSE Rancher stack. And SUSE has a commitment to a list of technologies that are specifically designed to work with upstream Kubernetes in default configurations. There are lots of very popular applications that work with SUSE Rancher and are available through the App Store no more than a couple of clicks away. So, enough talking. Let's take a quick look behind the scenes before proceeding to the demo. So first of all, from a topology point of view, we have the Rancher management instance, which is a combination of a number of technologies. First of all, the authentication proxy that can use and leverage third-party authentication sources, GitHub, Active Directory, SAML, among others. Then we have the Rancher API at the core of Rancher itself. It coordinates how to manage the requests made to Rancher. The bridge between Rancher and the downstream clusters is made through the pairing of agents and controllers. In the downstream agent, you see the cluster agent. This is basically a pod which initiates a WebSocket connection back to Rancher. There are two types of agents. The one we were just talking about connects to the API of that specific Kubernetes cluster. You also have the node agent, which interacts with the nodes in that cluster. It is a facilitator at the cluster level for upgrading Kubernetes cluster versions, for example, restoring etcd snapshots and so on. And it is also a fallback. In case the cluster agent goes away, the node agent can take over that communication. Notice that the users can connect this directly to Rancher or to the downstream clusters. At configuration time, you can make this available by setting up an authorized cluster endpoint in your downstream cluster. If Rancher goes down for any reason, you don't want to lose access to your downstream cluster. So this is very important. The workloads will continue to run anyway because you have set these clusters in a way that they are highly available. But this access ensures that you can still manage it if Rancher is not available. Rancher will have pushed down the CRDs, custom resource definitions, and it will have the same permissions at the end clusters, no matter if you're accessing it through Rancher or directly through the downstream cluster API. Rancher itself is a containerized application, and it is packaged as a Helm chart. And when you install it on a Kubernetes cluster. So it inherits the high availability capabilities of that cluster, and it can be installed on a cluster of any certified Kubernetes distribution. Although by far what is used more often is RKE, of course, the Rancher Kubernetes engine. You can simply spin a 3-node RKE cluster and you can install Rancher inside. It automatically installs an Nginx ingress controller, which runs on the host networking namespace. And that exposes node 80 and 443 directly on the node. In most cases, you have a load balancer in front of it, running outside of the cluster, and it is used to route traffic to the cluster nodes. The load balancer hosts a virtual IP, and that should be what the Rancher URL for your company resolves to. You can use L4 and L7 routing. So the topology is really simple. You have a Kubernetes cluster and you install Rancher on it. Very simple. Keep in mind that Rancher will not coexist with your workloads in the same Rancher. So that cluster will be exclusively for Rancher itself. Rancher manages downstream clusters, where typically there are several of them that run on the specific, the actual specific workloads that you have. So we have mentioned RKE and K3S, SUSE Rancher's own Kubernetes distributions. So let's look at their differences and where they fit best. As mentioned earlier in this presentation, different workloads have different requirements. And that is why the Rancher team at SUSE has worked on different Kubernetes flavors to tailor to different use cases. The first distribution is called RKE, Rancher Kubernetes Engine, aimed primarily at data center deployments, be it on-premise or on cloud. The installation is simple as fast. It can run on multiple types of platforms. For example, a VMware cluster, bare metal servers, virtual machine instances. It supports the x86 and ARM 64-bit architectures, and of course, Windows systems as well. The second Kubernetes distribution is called K3S, and this is a lightweight Kubernetes distribution. It's a very, very fun thing to use, to install, and to play with. It's a lightweight Kubernetes distribution. It is aimed primarily at edge use cases. It is designed for production environments in unattended with resource-constrained conditions and locations. In addition to being lightweight, it also reduces the steps needed to install, run, and auto-update a production Kubernetes cluster. Remember that SUSE Rancher can work with any CNCF certified distribution, including those provided by others, not only RKE and K3S. And now that you understand the use cases for RKE and K3S, let's look at some more details about them. RKE is Rancher's distribution of upstream Kubernetes. It's fully compliant to CNCF requirements and a CNCF certified Kubernetes distribution itself. It tracks the latest releases of upstream Kubernetes and adds a few bits and pieces that everyone really needs to effectively manage Kubernetes cluster at scale. It exposes the declarative configuration framework that Kubernetes is known for. As mentioned before, it is infrastructure agnostic. It fully supports using bare metal and virtual machines running almost anywhere, including the premise and the cloud. It fully supports all of the major Linux distributions, including, of course, SUSE Linux Enterprise Server. It is containerized itself, so it doesn't need any Linux distribution-specific package repositories. That gives you a lot of choices to where to run. Using the RKE command line interface, it is really simple not only to install a new cluster, but also to upgrade, downgrade, roll back, and perform backups and disaster recovery work. You can do that from both the command line, or you can also use Rancher to do it. You can also recover your whole cluster in a matter of minutes. RKE has support for recurring or one-time etcd snapshots. Cluster upgrades are a big focus of RKE. Kubernetes is a project that moves quite fast with very strong release cycles. So if you operate clusters, you need to do upgrades and patching very often. And you don't want these to cause any downtime on the applications. And this is something that RKE does really well. Finally, the rollback feature. If there are any issues with the upgrade, you can roll back both the Kubernetes version as well as the configuration. K3s, on the other hand, is a lightweight distribution, also CNCF certified, and aimed towards at-edge deployments. It comes as a single binary, everything you need to start running clusters under the default configuration. Because it is so lightweight, it lends itself very well for short-lived ephemeral clusters in resource-constrained environments, typically a Raspberry Pi, for example. There is also a massive adoption among developers for managing their pipelines and testing their applications, because you can actually run K3s inside of a GitHub action if you want and test your whole application inside of it. It's really, really cool. You can very easily run K3s on your laptop, on your Raspberry Pis, and it can even be packaged that run as embedded applications. So K3s runs on different platforms, and of course there are binaries for x86 and ARM architectures. You don't need a data center type of server to run it. It can run on any machine with very low resources. It removes all of the deprecated or non-essential components, and it even replaces etcd with SQLite, just to tell you how simplified it is. In addition, a lot of the configuration options have already been made for you. For example, it takes SQLite as the default data backend, but if you want, you can always choose to change it and choose etcd or even MySQL if that's your choice. At the same time, you can combine it with Fleet, which is a GitOps-based product we use inside of Rancher for doing application and Kubernetes lifecycle management. So it is very fast to stand up thousands of very small clusters that use K3s and then manage them and their applications via Fleet. For customers very interested in edge solutions, this is very important for them. Fleet is an open source project that can be used embedded for SUSE Rancher and can also be used independently. When using Rancher, Fleet can be used as a continuous delivery tool. In Fleet, the idea is to maintain the IT operations configuration in a Git repository. So the Fleet controller lives in the management cluster, and users can interact with Fleet through kubectl, which is the official tool to access Kubernetes, or having some Git pipelines set up. When DevOps or IT users want to change the configuration, they submit a pull request in the Git repository, and then through GitOps, the changes are applied. The Fleet controller listens for triggers from the Git repository and syncs the configuration changes automatically based on the single source of truth, which is Git. The changes get packaged into bundle definitions, which are groups of manifests, and bundles can contain configuration changes and workload changes. Each cluster has a Fleet agent, very similar to how Puppet works, right? Which contacts the Fleet manager to find any changes that need to be deployed. Unlike other deployment solutions, Fleet does not push the changes to the clusters. Instead, the Fleet agents pull the changes from the Fleet controller. So this is a change of paradigm. This is a crucial element of the architecture, as downstream clusters don't need a reliable connection to the management control plane. This also relieves resources for the Fleet management cluster. As soon as the cluster is able to connect, it will get its pending updates. And this facilitates management at a very large scale that is typical of edge deployments. In addition, there is a lot of flexibility in defining where bundles will be deployed to and what are the specific configurations of these deployments, as well as the rollout strategy to be followed. To facilitate the management of the deployments, Fleet uses the concept of cluster groups. Any cluster can be labeled with keys and values. And cluster groups use logical expressions on these labels that define the clusters in it. The Git repository is then connected with the resources in a specific group so that anytime a cluster is added to a group, the resources automatically get pushed to the new cluster in the group. This makes managing the edge devices a lot simpler. When a new device is deployed in the field, it just needs to be powered on, and when the appliance loads and K3s starts, the device gets added to the Fleet Manager cluster, and wherever resource is needed will be pushed to it automatically. But as they say, a picture is better than 1,000 words. And I have a video for you showing a lot about how Rancher works.
I'm going to do a quick overview of some of the features of Rancher 2.6. So what I'm looking at now is the cluster management screen, and from here I can really see all of my clusters. You can see I've got an RKE2 instance that's running in an AWS Dev Sandbox. I've got another local RKE cluster. Here's a full Amazon EKS cluster that we're managing with Rancher. This is running natively on Amazon EKS. And then I've got a couple other local RKE clusters. Now let's go ahead and take a look at one of these clusters. This cluster has the Rancher monitoring module already installed. And I can just click over and look at machines, and we can take a look at our nodes. And just to give you an idea, with Rancher, we really give you a view all the way through of what's going on in my cluster. So now I'm looking at an individual node here. We can see exactly what's running on that node. We can get some quick metrics. So I can see CPU, you can see average memory load, things like that, as well as what images are currently running. Lots of really good information, but let's not get ahead of ourselves. Let's jump back to this cluster view where we can get an overview of everything. Now, how do we get clusters into Rancher? Well, I've got a couple options. First, if I've got an existing CNCF certified Kubernetes instance, I can import it right from here. If it's an Amazon EKS or Microsoft Azure AKS, or Google GKE, it's really simple to do. In fact, I'll show you that. I'm going to click on the Amazon EKS. We can give it a name. And here's what's cool. So I've already put in my credentials. I'm going to point it to a region that has a cluster in it. And now I can choose an existing cluster that I've already got. I can hit register the cluster. What it's going to do is it's going to do a deployment of the Rancher agents into the cluster, and then we're going to be able to completely manage this cluster. Now I'm going to hit cancel out of here and show you another way that we can do an import. So let's say that you're trying to import a cluster that is not in one of the big cloud providers, and it's just a standard CNCF Kubernetes instance. That might be our K3s. All we need to do is click on here. We're going to give it our name. I can do a couple customizations. I can add variables and labels that we'll be able to use later. But for now, if I just hit create, what it's going to do is it's going to give me commands that I can run on that machine. So really all I need to do is to copy this command, and you can see it's just a kube control command. So it's really just it telling that version of Kubernetes to deploy this specific job, and this job will contain everything that we need to make that a Rancher managed cluster. It'll have the cluster agents and everything that is required. So now, what if we want to create a cluster? Well, here we can go to create, and you see up at the top what we've got are, again, the big Kubernetes providers, Amazon, Microsoft Azure, and Google. And with those, what we can do is we can actually go in, create one, and what it'll do is we'll call this UI dev cluster. And then we can pick the region we want to put in. I'll put it in US East. My credentials, which I've already added. Now I'll go into the cluster config. And then you can see here I'm going to be able to start to get granular. I can select what version of Kubernetes I want. We can get into our network config. We can change stuff, or we can leave it as the default. The defaults are fine. We can set up any of the security groups we need to. The only thing we need to do is we do need to give it a node group name. So we're just going to call these nodes Kubernetes. So these are just going to be like the worker nodes that will need to be created. And then if I hit create here, that's going to go ahead and create the nodes, set everything up, and I'm going to have a full cluster. I'm going to cancel out of this. And let me show you what that experience is if I wanted to create an RKE host. So let's just say I had just a normal machine. The only thing I had on it was Docker. I could just go to custom. And now I can create my node. So this is going to be... It's going to be just a local RKE. So again, I can select my version. One of the things that I like about Rancher is we always say that batteries are included but optional. And this is another great example, right? We've defaulted to Canal as the network provider, but you easily can go and change it to Flannel or to Weave or whatever you want. So now I'm going to go down here. It's going to ask me if I'm using a cloud provider. Since I'm doing this local, I don't need one. If I've got a registry, I can put in that information. When we get into advanced options, these are, again, some of those cool defaults that Rancher gives you that really helps. So here I've got Ingress enabled by default using these specific ports. Do I want pod security turned on or off? Do I want to require a specific version of Docker? You know, I can get into it. I can encrypt stuff. I can decide when I do timed backups, which we're going to get into it in a minute. But one of the cool things about a cluster deployed by Rancher is we're going to automatically do snapshots. And as you can see here, I'm going to do a local snapshot every 12 hours, and I'm going to always keep the at least the past 6. And we can also, you know, automatically schedule CIS scans and stuff. So I'm just going to hit next. Now, if I want to create this cluster, all I need to do is I'm going to select etcd and control panel, and now I can copy this entire command and go paste it in. If I wanted a 3-node cluster, I would just paste this command in 3 separate nodes. If I wanted 3 nodes plus a bunch of workers, I would copy and paste that in 3 worker nodes, and then I just unselect etcd and control panel. And if I just want workers, I copy and paste that as many workers as I want. That's what's nice. You just copy and paste the same command. The only thing you're changing is what the node roles are. So I'm going to hit done, and we're going to see that's provisioning. It's just waiting for nodes to come up. Now here's another thing that I really like about Rancher. I showed you how when we deployed Rancher, how we could go in and we could really tweak things. We could, you know, select our Kubernetes version. We could turn Nginx on and off. Well, another neat thing is we can do that after the fact on these fully managed clusters. So now I'm going to go down here and I'm going to drop these 3 buttons, and you'll see we've got a couple options. You know, I can do a kubectl shell, which will obviously put me right at a command prompt where I can do kube control commands. I could download the kube config. I could take a snapshot. Again, remember Rancher by default is going to take a snapshot every 12 hours, but you know, we're about ready to play with stuff, so let's be safe. Let's just do a snapshot. So now what that's doing is that's backing up all my objects, etcd, the cluster configuration, and the version of Kubernetes. So now let's go back to that cluster. We could rotate the certificates. We could make this, you know, like a template so that when we build additional RKE-based clusters, we're building them off a template that's identical to what we used to create this. And we can also go in and edit the config. And this is what's cool. We could, you know, we can change the name of the cluster, but I can also go in and really change anything about this. So first, let's upgrade this. It's currently at version 119. Let's take it to the absolute version, the absolute latest version, 2.15. And then, you know, if I wanted to disable Ingress or any other thing, that's what I love is I can, after the fact, go ahead and make changes. So now we've told it to upgrade. I'm going to hit save, and I just have to hit done, and it is going to actually do that upgrade as we talk. It's going to do a backup, it's going to upgrade the cluster, and then come back online. Let's show you a couple cool things about a cluster. Now this is the cluster we looked at earlier, where I just gave you the brief glance where we could see what was going on the nodes. So that's where I'm seeing my existing nodes that are running on Rancher. Here's registration. So let's say after the fact, now I want to add another worker node. All I need to do is select just the worker node, copy that, and go paste that in a terminal prompt of any other machine that I want to turn into a node. Again, all it's going to need is Docker running. Here are all the snapshots that I've got it if I wanted to do a restore, right, I can easily restore any of these just by clicking on there and hitting restore. And if I do that, you'll see it gives me the option that I can restore just etcd, just the database, the Kubernetes version and etcd, or everything, the cluster config, Kubernetes version, and what have you. Config. So that's really Cluster Manager, where we can see what's happening with these clusters. Now, let's dive down and really see what's going on with the cluster. So again, we've got our SAN prod cluster. So let's go into Explorer and take a look at it. So here we're getting real nice details. We can see the total resources running, the amount of nodes, the deployments. Again, because we've got monitoring installed, I'm seeing actual real data, real graphs of what's happening. And this is one of the things that I really like, is I've got the ability to really drill down and see exactly what's going on. So let's take a look at some of the workloads we've got running here. We've got 16 different deployments. Let's go take a look at one of these. Here we've got Node-RED, which is a development environment. Let's take a look at that deployment. So we can see we've got it running. There's an instance running directly on Node 4. We're going to click in and take a look at that individual pod that's running it. And when we get here, there's a couple of things that I really like as a technical person that help me troubleshoot things. The first is I can quickly see that it's active, that it's working. I can jump over to metrics, and I can see exactly what CPU utilization, memory utilization, and things like that are happening, as well as recent conditions, right? I can see, okay, this is healthy. I can see that it spun up, it initialized, and it has been in a ready state for 9 hours. So that really helps me understand the state. If there are issues, what's great is it's really easy for me to debug stuff here. A couple of things that I can do is, first, I can just click right there, and I will be directly in the shell of that pod, and I will be able to do commands and do whatever I want, right, to see exactly what's going on. But the great thing is I can not only execute that shell that I just showed, I also have the ability to view the logs, which will show me the logs directly in that pod and everything. So that really helps me quickly see not only what's going on in the cluster, but really dive all the way down to see something that's running, view its logs, view its metrics, and everything. Okay, let's jump back to Cluster Manager for a minute and talk a little bit about users and roles within Rancher. And you can see here we've got a couple different users. Let me show you an easy way to get users into your system. Yes, you can manually create them as you want, but it's also real easy in Rancher to bring in third-party authentication modules. Whether that's Active Directory, Google, Okta, it doesn't matter. To give you an idea, Google, you click on it, and again, one of the things I really like, very easy to do, right? I just have to fill out this form, the admin email address, the domain, and then I walk through these exact steps to do it. If I take a look at Active Directory, same thing. I pretty much just fill out a form, hit enable, and I will automatically be able to see users directly in Rancher. Let's talk a minute and talk about what kind of roles we can grant users. When Rancher needed to figure out how they were going to handle security and roles for their application, I really like the way that they solved it. What they did is they took a look at the current roles that are available in Kubernetes and realized that they could easily enhance those to really get fine-grained detail on what users are allowed to do within Rancher. So let's take a look at that. If I jump over to roles, you see we have 3 different categories. The first are global, and these are really the Rancher level roles. So here I've got, administrator, I've got configure authentication, use catalogs. These are all the different types of things that you could do within Rancher. In fact, one of the things that I like is the restricted admin. Let's take a look at that. Here's all the things that the restricted admin can do. So I can really get down and see exactly what it is they're able to do. And if I wanted to, I could configure it and tweak it and modify it. So we'll jump back. So again, these are all roles of what they're enabled to do within Rancher. And then if we kind of take the next step down, this is really Kubernetes roles. So this is what would they be able to do at the cluster level. Are they allowed to create cluster members? Can they manage cluster backups, right? It's all those. These are really just standard Kubernetes-based roles. And then when you get down to projects and namespaces, that's kind of where you would sign rights for an application owner, right? You give somebody the ability to manage a specific either project or, a subset of a project, a namespace within Kubernetes. And that's the great thing is now I can easily take those users and we can come in and edit the user and just grant them whatever rights we want. Are they going to be, I've made him a restricted administrator, I can make him a standard administrator, and can go in and really tweak what I want him to have the ability to do. Earlier we talked about backing up a Rancher deployed cluster or a Rancher manager cluster, and we showed how snapshots are automatically done every 12 hours. What about backing up Rancher itself? Well, what's cool is this actually gives you a good example of how easy it is to turn on and install enhancements to Rancher. So let's go to Cluster Explorer for our Rancher cluster. Now all I'm going to do is I'm going to go to Applications and Marketplace, and I'm going to go to Charts, and I'm going to look for a chart called Backup, and that's a Rancher provided chart that will set up an operator that will automatically do our backups. So now all I need to do is it gives me nice information to read, but to be honest with you, all I need to do is click on Install. It's going to ask me a couple basic questions. I'm going to tell it that I want to customize this chart, and I'm going to point it to an existing storage class, which is just my local path, which means it's going to do all the backups local. But I could easily point it to an existing persistent volume or any S3 compliant object storage. And I'm going to hit install. And you'll see in just a couple of seconds, the system's going to install that and configure everything, and we'll be ready to do backups. Okay, the install is completed, and we can see we now have a new option called Rancher Backups. We can create a backup simply by hitting Create. Call this our initial backup. This will be one-time backup, but if we want to do reoccurring, simply cron nomenclature right there. But we'll do a one-time backup. And we'll see in just a minute, everything about Rancher will be backed up and all the information that it needs. Now the backup is stored on our local storage. Remember, we also have the ability to simply download the YAML so that we have a copy local so that we can then upload it if we needed to. So this is one of those things that I back up before I do like a Rancher upgrade or anything. I not only back it up to its local cluster, I also back it up locally, and then I download that config just to cover myself. There is one more thing I'd like to show you. Let's jump back to our cluster management. And let's take a look at this SAN production server. I want to take a look to see how well my cluster is configured. Is it secure? Is it safe? Is this something that I could deploy out on the internet and I would be all right? Well, we give you some great tools to do that. So what I'm going to do is, again, I'm going to go to Apps and Marketplace. And here I'm going to search for CIS. And you'll see a chart that we automatically make available when you install Rancher is CIS benchmarks. I've already installed it on this cluster, but again, it's as simple as I clicked on install button here and it installed itself. And again, in less than a minute, I had a system up and running. And then I had this option over here, which is CIS benchmark. So I've already done one quick light scan that passed, and we'll go in, we'll take a look. You can see it did pass, although it did give me a couple warnings. So let's go ahead and run a scan that I know is going to fail. Just to give you an idea for the kind of things this tests for, the nice thing is this was not set up by SUSE. This is industry experts that have really defined these CIS benchmarks. So now let's go ahead and really do the heavy hardening test. I know this is going to fail because I haven't done anything but create this cluster, so it's in the default shape. So we'll go ahead and let that run, and it'll just take a couple seconds to run. So we can dive in and take a look and see exactly what it found. Sure, of course, I didn't think to check the directory ownership of etcd, right? These are things that I never would have thought of that it's found that could be security holes. So that's great. It now gives me a whole checklist of things that I need to go to really secure on this cluster before I make it accessible on the internet. So again, great CIS benchmark marks already built in. You just have to turn them on and enable them.
Good. So here we are. I hope the demo showed you the interesting features of SUSE Rancher and how it is a very comprehensive, very complete multi-cluster management solution. So what to do next for you who are watching this webinar? Well, first of all, please join the SUSE and Rancher community. There's a lot of users there sharing very good tips and tricks and helping each other. So it's a really, really interesting way to get started. Remember that Rancher is an open source project, so you can basically install it without any further requirement. SUSE organizes Rancher rodeos. So this is very interesting. They go all over the world talking about Rancher, what Rancher can do, and all of the different integrations and all of the different possibilities. And people from the community as well appear on those Rancher rodeos. I actually had to present at one of those rodeos in Zurich. So it's a very interesting way to learn. So please check out SUSE.com/events for the next Rancher rodeo. It might as well happen in your own city. And in Vision, we also provide a DevOps workshop. So if you are interested in knowing more about Rancher and you would like to implement it in your own enterprise, please let us know. We will be very happy to help you in collaboration with SUSE, of course. And of course, please feel free to ask any questions you may have right now on the Q&A box. But in the meantime, I would like to thank you a lot for attending. Thank you so much for your patience with the sound issues. And of course, any questions you might have, please contact me, adrian@vision.ch. Or, of course, contact SUSE directly. The contact information is on the screen. Thank you so much for attending. I will stop the recording now. And if you have any questions, please post it on the Q&A box. I will be very happy to answer them.